All right, so we're going to be looking at 7.5.4, the distributive property. It begins on page 375. And again, this is just reviewing what we've gone over and maybe adding a little bit extra to it since we now have the integers. So the real world scenario is that Jordan buys 3 notebooks that cost $5 each, and he also buys 3 packages of pens that are $6 each. I'd like for you to pause the video and go through 1, 2, 3, 4, and 5 and answer them. And when you come back, I'll have the answers and go over it with you. Alright, so Jordan buys 3 notebooks that cost $5 each, and he also buys 3 packages of pens for $6 each. So writing the expression that shows the cost of 3 notebooks added to the cost of 3 packages of pens would be 3 times the 5 plus 3 times the 6. Or writing the expression that shows 3 times the cost of 1 notebook and 1 package of pens can be written as 3 times 5 plus 6, and that'll give you the $5 plus the $6 times 3. So we've got to evaluate both expressions. What do you notice? They would come out to being the same answer. It's just distributive property, so we're using distributive property. That's what I would say would be a good answer, that we could add the total money first and then multiply it times 3 since they have the same amount of packages. Then number 4 says, suppose Jordan buys 5 notebooks that cost $3 each and 5 packages of pens that cost $1 each. Circle the expression that represents Jordan's purchases. And so we've got 5 of one and 5 of the other. One of them's 3 and one of them's $1. I would say going with this or going with this one. Okay, so those are the 2 expressions. Now the one in the middle won't work because it has multiplication in the middle, and we're not multiplying everything, we're multiplying the 2 sets and then adding them together. Alright, suppose Jordan buys 2 rulers that cost $1 each and 2 folders that cost $1.50 each. Circle the expressions that represent what he's saying. That would be 2 times $1 and plus $1.50, or 2 times 1 plus 2 times $1.50. So these 2 would work. This one is just all adding, and that will not work out. That's like saying $2 plus $1 plus $2 plus $1.50 instead of 2 times $1 plus 2 times $1.50. Alright, so using distributive property, vocab, go ahead and write this down. Distributive property states that to multiply a sum or difference by a number, you multiply each term inside the parentheses by the number outside the parentheses. We also called this rainbow. Okay, I want to see the pretty rainbow. I want to see you show your work. Even if you're using the calculator to actually solve those pieces, I want you to show me what you're doing so I can see that you know that it's going to be A times B minus A times C. Alright, now the model, you can model distributive with algebraic expressions using the algebra tiles. I don't need you to write down these pictures unless you find them very helpful. The first one says model x plus 2 using algebra tiles, and then doubling the amount we would do another set of x and then the 2 tiles for the ones, and then we can rearrange those by saying 2 right here and then 1 and 1 and 1 and 1, which is 2x plus 4, or 2 x's plus 2 sets of 2, which is 2 x's plus 4. The expression 2x plus 2, or sorry, 2 times x plus 2 and 2x plus 4 are equivalent expressions. No matter what x is, these expressions have the same value. And that's because of distributive property that's okay. So this is another one of those properties, just like associative and commutative and all those other properties that we've learned just the last section, that make it so that these can be equivalent. Because if it was other operations, maybe we wouldn't be able to do that. But this is multiplication going into either addition or subtraction. Alright, so here's some examples. Example number 1, use distributive property to evaluate x times negative 9 plus 4. So, of course, we can look at this and say, well, why don't we just do negative 9 plus 4, but we're not, because it says to use distributive property to solve this. So we're going to do our rainbow. So you should have 8 and then in parentheses negative 9 plus 4. We're going to do 8 times negative 9, which is negative 72, plus 8 times 32, which is, 8 times 4, which is 32. Then we can put these together and get our negative 40 because it's different signs subtract. And take the sign of the higher number. Absolute value. All right, so negative 40 is the one that we're looking for here. I hope that they give us an example, and I'm sure they will. Good. I want to do this example B with you before you do it on your own, since essentially that's what C is. You can change the order of where your multiplication goes and put it 9 times 12 minus 8. You can rearrange those if you'd like for that one. But I want to talk about B. So we're going to skip straight to B first. You'll do A and C on your own in a moment. But B, I want to do first with you. So we've got 7 times, in parentheses, 10 minus 5. So doing my rainbow, I'm going to do 7 times 10, which is 70. I'm going to bring down my minus sign. And then I'm going to do 7 times 5, which is 35. If I thought of this as negative 5, notice that 7 times negative 5 would have come out to negative 35 and given me that minus sign. You have to either put it together or keep it separate. So I like to drop down the sign. That's always how I do it. And then do it times this number, do the multiplication times this number. But if you're making it times a negative 5, then don't bring down anything. Do it 7 times negative 5. All right, so then we're going to get a positive 35 as our final answer. So that's the answer for B. So I want you to attempt to do A and C on your own, and we'll come back and go over the answers. Pause the video now. So for A, we have 5 times negative 9 plus 11. We're going to do our rainbow. And so we're going to do 5 times negative 9, which is negative 45, plus, because I'm bringing down the plus sign, 5 times 11, which is 55. So negative 45 plus 55, opposites we subtract. Different signs you subtract, and you take the sign of the higher absolute value, which is positive, and 10 should be your answer. For C, we're going to do, and I changed it to this order, but if you're going like this with your rainbow, that's fine, but put it back in this order. I need you to do the first one and then the second one. So it's going to be 9 times 12, which is 108, minus, and again, I told you, I bring down the minus sign because that's how I think of it. And then I do 9 times 8, which is 72. So I end up doing 108 minus 72, which is 36. And that's positive because this is a really easy subtraction problem, 108 minus 72. All right, now number 2 example says use the distributive property to rewrite each expression. So we're doing our rainbow, but we're going to write it out because we can't solve it. We have variables that we can't solve for. So it's no longer that we even have the option of adding what's inside parentheses and then multiplying. We actually don't know what x is, so we can't solve it. We're just rewriting it or simplifying it. Okay? So we know that we're going to do our rainbow, 4 times x plus 4 times 7. And so ultimately we're going to get 4 times x plus 28. And that's simplified. For this one, we're going to do 6 times p minus, bring down the minus sign, 6 times 5, which is 30, and so we end up with 6 times p minus 30. They showed making it just bring down a plus sign. I don't do that. I like to bring down the sign that they give. So you could use either option. Like I said, you figure out that it's a negative number regardless. That's negative 30, and then you're ultimately going to subtract. So I think just bringing down the sign is easier. Number 4, though, and I like this. So number 4, the way that I would do it, I'm going to show my work down here, is I would say, okay, negative 2 times x is negative 2x. Bring down the minus sign. Negative 2 times 8 is negative 16. When I have negative 2x minus a negative, you should know by now that minus a negative is the same as adding its opposite So it's really saying this. Would I take this answer? Yes, I would. I would take negative 2x minus a negative 16. If you gave me negative 2x minus 16, that would be wrong though. It needs to be either plus 16 or minus a negative 16. So those are the two answers I would accept. All right, so looking at number 5, example number 5, I'm going to do my, and it's really just a case of simplifying because we, again, don't know what x is, and now we don't know what y is either. But we're going to do negative 5 times negative 3 times x. You can separate it out if you want to put the multiplication sign in there and say negative 5 times negative 3 times negative, or times x. I would put these two together to make 15 times x. So that's how I would simplify. Oh, sorry, it's not negative 5. I don't know where I get my information from. It is 5 times negative 3 times x, which is negative 15 times x. So that's right here, negative 15 times x. Then 5 times 7 times y would be 5 times 7 times y, which I can do this part right here to make 35 times y. And so now we're just going to put the two together. Negative 15 minus, or sorry, trying to draw and change things at the same time. Negative 15x plus 35 times y. And that's our final answer. All right, example number 6. 1/3 times x minus 6. Again, we're just doing our rainbow, where we're going to say negative 1/3 times x. Sorry, I don't know why I keep saying things wrong. Sorry. It's just positive 1/3 times x minus, because I always bring that down, 1/3 times 6. When I do 1/3 times 6, I'm going to make this into a fraction, cross simplify, and I end up with 2 and 1. So it's 1/3 x minus 2 over 1, which is 2. And that's your final answer. Now you're going to do D and E on your own. Make sure you show your work, because you can't solve these, so I want you to show your work and use your rainbow. All right? Pause the video. All right, so here are the answers for D and E. Just doing the rainbow, 6 times A, and then 6 times 4, so it's going to be 6A plus 24, and then 8 times M plus 8 times 3 times N, so that'll be 8 times 3, then times N, which is 24N, so 8M plus 24N. And then now do F and G if you haven't already done that, and I'll come back and show you the answers to those as well. All right, so for F, you should have either negative 3 times y minus a negative 30, or negative 3 times y plus positive 30. So those are the two options for that one. I'm fine with either one. For G, I've got 1/2 w minus 2. Sorry. And then example number 3 says Mr. Ito needs to buy batting helmets for the baseball team. The helmets he plans to buy are $19.95 each. Find the total cost if Mr. Ito needs to buy 9 batting helmets for his team. So it says to change, oh, okay, if we're trying to do mental math, we can change it to $20, which means we're doing a 5-cent increase. So we can do 9 times 20, which is 180, but that's not exact. So then she's saying, let's take away the 5 cents for every helmet. So we're going to do 9 times 5 cents, which is 45 cents. And then we can say, okay, it's $180 minus 45 cents, so it's $179.55. I love it. Okay, so that's just trying to use mental math. And those are strategies you might have learned back in elementary school, where you know, it's easier to do mental math on nice round numbers, but then don't forget to take away the extra stuff. So that's actually using distributed property, because you're doing 9 times the 20, then you're doing 9 times the 5 cents, and then you're subtracting the two numbers. So you're going to do H, which is a sports club rents dirt bikes for $37.50 each. Find the total cost for the club to rent 20 bikes and justify your answer by using the distributive property. And so this is an example just like the last one that we did. So you're going to want to round this to a nice easy number to work with and then subtract accordingly. So pause the video now so that you're able to do that work, and when you come back I'll go over the answer. Alright, so what you could have done is, and it's completely up to you, but you could have changed that to $40, which is a nice round number, and that means that you are overestimating by $2.50. So you can multiply times 20, and they want you to use distributive property, so this is how it should work, where you've got 20 times the 400, which is $800, minus 20 times the $2.50, which is, okay, that one I can't do in my head, so 250, 2 times would be $5 times 10, so $50, and you would get $750 is how much you spend on the bikes, or for the club to rent the bike, sorry. I'm just going to double check that to make sure it's right. Alright, double check that to make sure I was right, and I was. Yay for me. Alright, so $750 should have been your answer for that one. Alright, that ends our lesson on distributive property. I hope you enjoyed it.